Folks, and welcome to our video on bile synthesis disorders and circulation. So this one's mostly going to be talking about things relevant to jaundice and gallstone problems, because those are the main pathologies involving bile in the body. So I suggest that you guys have a look either before or after this at our videos on jaundice and on other related pathologies, because it'll make a lot of sense. The idea of this one is basically to give you the background knowledge physiologically to understand what is going on with those diseases and why we get certain symptoms and why we expect to see the things we do and what we can do about it, basically. All right. So you guys should remember the bile contents from our earlier video on gut secretions, but just to recap a little bit, we have cholesterol, which is mostly there as a precursor of one of the main actual contents, bile salts, which we actually are going to go over the formation of. We also have lecithin, which is basically a phospholipid itself and produced from more mundane phospholipids, electrolytes and water you just get from your diet, and bile pigments, which we get from breakdown of heme. So the bolded ones we're actually going to go through in a little bit more detail and understand them. So as it says at the bottom, we're going to be talking about bile acids for most of this little video, and we're not going to call them bile salts. The only difference between them is that bile salts are the ionized version of bile acids. So you don't need to make too much distinction between the two, other than to understand that bile salts are the ones that actually functionally do the work, and bile acids mostly serve as sort of intermediaries. So when they're being changed and altered and synthesized, they're usually bile acids, and then they get converted to bile salts in order to do their job. Okay. So yeah, let's talk about bile acid synthesis. So we already know it starts from cholesterol. That's the one thing we know for sure. The most important thing in this whole pathway is pretty complicated, and this could be more complicated. There's many other steps involved. But the only really important thing that you need to understand is that we have an enzyme here called 7-alpha hydroxylase, okay? And if it does not work, the entire thing doesn't work, because cholesterol just stays as cholesterol, and we never make any form of bile acids or bile salts. Chenodeoxycholic acid and cholic acids are what we call our primary bile acids, and they require 7-alpha hydroxycholesterol to actually be made, okay? So in other words, if we increase 7-alpha hydroxylase activity, we make a lot more bile salts and bile acids. If we decrease it, we get a deficit of bile salts and bile acids. And so we can basically control the bile content and the bile creation of the body by altering 7-alpha hydroxylase's action. So normal regulation of bile acids is not super important for you guys to understand, but more important is that we can artificially change the action of 7-alpha hydroxylase. So funnily enough, it's actually usually a good thing to increase bile acid synthesis, and that goes for both when we want to decrease blood cholesterol, which we do because 7-alpha hydroxylase actually converts blood cholesterol taken up by the liver into these derivatives. And also when we want to deal with gallstones. We're going to talk a little bit more about those in the next slide, but suffice it to say, the more bile acid and bile salts we have, the better in terms of gallstone formation. In other words, it's a sort of a protective measure against them, okay? So yeah, if you go and you look at things like primary and secondary bile acids, we'll cover them briefly, but you don't need to know them in too much detail. The really important thing, remember 7-alpha hydroxylase and this whole little pathway we have here. Okay. Oh, there we go. So basically, the idea is we have too much cholesterol and we don't have enough bile salts and we don't have enough phospholipids. And then all the cholesterol starts to clump together and we form gallstones, okay? So you'll usually hear this described as cholelithiasis. So that's the presence of gallstones in your bladder, and basically means anything from 1 to an entire gallbladder filled with gallstones. If any of them slip down into the common biliary tract, so you got your gallbladder here, you've got your tract from the liver coming down, they form the common bile duct. If any of the gallstones slip down into there, we call it choledocholithiasis. If the presence of gallstones in the gallbladder makes it inflamed, we call it cholecystitis. And if we get inflammation in the actual biliary tree instead, then we call that cholangitis. And often you'll hear it described as ascending cholangitis. So that's usually what we associate with Charcot's triad. So in which we get sort of pain in the right upper quadrant, we usually get jaundice, and we get one more fever. Fever is the third part of that triad. But you'll hear a lot more about that in terms of the actual investigation of jaundice video. So in terms of causes, so what's actually messing with bile synthesis, usually it's something wrong with the liver, because the liver is basically the be all and end all when it comes to bile. Okay, so either we're not making enough normal bile acids to sort of counteract the cholesterol, or we are making bad bile acids, abnormal, non-functioning, that sort of thing, or there's some sort of blockage of bile flow down from the liver, which is preventing it from getting into the gallbladder, which is where we usually get gallstone formation. Okay. Computer is lagging out again, unfortunately. There we go. All right, so the enterohepatic circulation is a fancy word for putting stuff from your bile duct into your gut, and then from your gut into your portal vein, and then from your portal vein back into your liver, and from your liver back into your bile duct or biliary tree. Okay, so you can see there on the right, that is basically the whole circuit that we're talking about here. So we make all these bile salts in the liver, we shove them into the intestines. They're going to serve their purpose in helping us digest fats. And then about 95% of them hop back into the portal vein, which you'll hopefully know by now, basically supplies venous drainage to most of your gut, hops into the portal vein sucks them all up and takes them right back to the liver. If we instead get breakdown, so usually it's broken down by bacteria in your gut, that 5% or so, a very small amount usually, it gets broken down into secondary bile acids, and then it gets excreted, okay? And so we actually lose that. So that's the reason we need to continually create bile, because even though a lot of it is actually recycled, and so we have a good amount of sort of persistent bile, we still need to make more because we're losing a little bit. Obviously, if we start losing more, then that's a problem, okay? Will that cooperate this time? Maybe, hopefully. Perfect. Okay. So the other thing we want to talk about in terms of bile is bile pigment. So this is a separate thing to bile salts and bile acids, but it's very, very relevant in terms of jaundice. Okay. So the pathway that we talk about here is basically from heme all the way down to different forms of bilirubin and bilinogen. Okay, so we start at heme, which is a precursor to hemoglobin. It gets converted. It's good to know the enzymes, but it's not necessarily super high yield. It gets turned into biliverdin, which is green, and then bilirubin, which is more sort of reddish, okay, or orangish sometimes. And so bilirubin and its derivatives are usually the ones that we find in bile, and that's what we call the bile pigments, okay? So the bilirubin is really the important thing. So we get what we call conjugated bilirubin, which is basically, like we talked about before, when you sort of ionize them and make them able to dissolve in water and then move around the body more easily. So once we get that, most of it is meant to go into your gut. In fact, all of it's meant to go into your gut. And then from there, a bunch of it is meant to become stercobilin or sterco. So, okay, the difference between bilin and bilinogen is just whether it's oxidized or not. So don't stress too much about those. But basically, it gets turned into stercobilin, which is a really sort of dark brown pigment. And that's what gives feces their color. So, you know, why your poo is dark. Some of it becomes urobilinogen or urobilin. And that's what it doesn't really give much color to your urine, but it gets excreted through your urine, suffice it to say. And then you get a little bit of recycling. So it's not a major pathway. The major pathway, most of it is just going shunted into your poo and then excreted, okay? A little bit of it gets put back into the enterohepatic circulation, and then actually cycles again and again. So in jaundice, I'm not going to cover in too much detail because this should already be covered in the actual jaundice video. But if you think about it, so if we have pre-hepatic jaundice, i.e. something is going wrong before the liver, then we don't really have any changes in all of this coloring. It's just a sort of deficit of heme, which is usually fairly even. If we have intrahepatic jaundice, so something is wrong inside the liver, then we'll still get bilirubin hopping down into the gut to become stercobilin. So the poo will still be brown, but we'll also have a lot of bilirubin all around the place, which will eventually become urobilinogen or urobilin, and then it will turn your urine dark. Okay, and if we get post-hepatic jaundice, where there's a blockage somewhere in the biliary tree, we're going to get still dark urine because we're getting back up almost. So there's still heaps of bilirubin floating around in your circulation, which gives you dark urine. But then you also don't get stercobilin in the feces. And so we get pale stools. So really the whole point of this video is to get you thinking about how both bile salts and bilirubin circulate and how that actually explains the symptoms that we see. Because you don't really want to be sort of rote memorizing these things. You want to be able to say, okay, I understand why this particular pathology is resulting in these symptoms, because it'll make it easier to understand and easier to think about and to conceptualize. So hopefully we've done that a little bit. Thank you very much, and see you in the next video.